Hi, welcome to question 2 of the 2024 Leaving Cert Ordinary Level Paper 2. As always, if you want to copy these notes, send this email to shanetroy@gmail.com, like and subscribe to get access to more videos. So this is a probability question. Part A is a 10 scale, okay, and let's read through it, but as always, pause the video and just see can you get it yourself. It'll make a more definitive link in your head. But probability can be tricky, so I appreciate that that's not always the case, although this part A isn't terrible. Sean is playing a game with 14 cards. 7 of the cards are green and they're using the letter G to represent that and numbered 1 through 7. The other 7 cards are red and they're numbered 1 through 7. So part A says complete the table below to show all the possible outcomes where a card is chosen. Some have already been completed for you. For example, G2 means the green card with the number 2. So you see here the G corresponds to green and the 2 corresponds to 2. Similarly, the R5 corresponds to red and the 5. So it's pretty straightforward. This is G1, G3, G4, G5, G6, G7, R1, R2, R3, R4, R6, R7. That's it. So not terrible, but like all probability questions, make sure you read it multiple times just to make sure there's no trick. But in this case, there isn't a trick. Now, part B says a card is chosen at random. Work out the probability of getting a card with an even number. Now, an even number is always divisible by 2, okay? So we need to look and think about the formula for probability. Now, I always remember this because it's not in the maths tables as flicking a coin. Okay, in a flicking a coin situation, there's 2 possible outcomes. One will happen. So the probability is given by the number of possible things. In the case of the coin, that's 2 things. The number of actual things that happen when you flick a coin is 1. So you get the probability of 1 over 2. So that's kind of how I generally remember the formula. Now, in this case, I've put in the data and I've kind of went, well, G2 is even, G4 is even, G6 is even, R6, R4, R2. So there are 6 options. Now, there are total possible outcomes. There's 14 numbers or 14 whatever, and we're only talking about 6 of them. So our number of possible is 14, our number of actual is 6. That should get you the marks, but we always try to leave our answer in the simplest form. Run through the calculator, it'll give you a 3 over 7. Or if you look for a number that will divide evenly into top and bottom, that will simplify it. In this case, 2 into 6 goes 3 times, 2 into 14 goes 7 times. So our answer is 3 over 7. No need to go decimal unless they ask for it, but you can if you want. Now, part C, okay. So Sean picks a card, and just to note, this is a 15 marker. Okay, so it's the chunk of marks here. If you're struggling with these kind of questions, just try something. Okay? You never know what will get you the marks in terms of the marking scheme. I'm just looking at it here. For parts, actually part C and D are marked together, so we are not even looking at D yet. So Sean picks a card at random and doesn't replace it. It's a red 5. Okay. He then picks a second card at random. What is the probability that the second card is a green card? Now, looking at the data is going to help, okay? But this is an example of an independent event. What you chose in the first selection doesn't affect what you choose in the second selection. That's what an independent event is. It's like flicking a coin. The second time you flick the coin, it doesn't matter what you got on the first one. It's an independent event. And there is a thing called the gambler's fallacy where people kind of think that just because they have like 3 or 4 heads in a row, or tails must come up next. It's due, okay? And that's just not what it's that probability, okay? And that's called the gambler's fallacy. So the picking of the second card is not affected by the choosing of the first. So because we've chosen one card and didn't replace it, that's why it's highlighted. We have 1 less card. So we start off with 14, or did we? I think I have a typo here. That should be 13, okay? So after picking the red 5, there are only 13 cards left. There was 14. There's our probability formula, which again, right now can maybe get you the low partial if it depends on how the marking scheme is interpreted. But there's 7 possible green cards, okay? And there's now only 13 cards left in our selection. So our probability is 7 over 13. You can't simplify that. It's already in the simplest form. That's the answer, okay? Now getting part C on its own, you would get the high partial of 8. Okay, so if you got this, you got 8 marks. or we get work of merit in both parts, you'll get the mid partial of 6. Okay. Now part D is tricky enough. Okay. Sean puts the 2 cards back. Then Sean picks a card at random and doesn't replace it. So similar. Okay. He then picks a second card at random and says, find the probability that the second card is a different color and a different number from the first card. Now, looking at the list of data here will really help. Okay, so I've kind of went, imagine if we picked G1 as our first card. Okay, well then R1 is out because it's the same number. Okay, we have to have a different color. There's only 6 options left. Okay, now because we've chosen a card and not replaced, like part C, there's only 13 cards left. So the number of actual things is 6. The number of possible things is only 13 because we've already selected, in my example here, G1. Now, I struggle with these questions personally. Always have a probability. I kind of either underthink it or overthink it. Practice makes perfect. I've gotten better and better and better over the years, but I still always kind of take a step back and I'll maybe read the question multiple times. Still might overthink it, but you have to do your best, especially with the trickier probability questions. So that's the end of question 2. So again, if you want a copy of these notes, just send an email to shanetroy@gmail.com and like and subscribe to get access to more videos. Best of luck.